Hello, welcome to another episode of sCrypt programming tutorials. In this video, I'm going to show you how Sighash types work. So as we have seen before, we have introduced the concept of Sighash preimage. So today I'm going to cover the last field called Sighash types of the signature. So what is this? It's also called Sighash types. So basically, if you still remember, we mentioned the Sighash preimage basically is what's going to be hashed and then signed into Bitcoin signatures. And usually the whole current transaction is included by default. And Sighash flags basically enable us to choose which part of the transaction we want to include it in the signature. So again, here we have some simple diagrams. We have transaction on the left, we have inputs, on the right, we have outputs. And if it's a blanket, it's unsigned. If it's colored, then it's signed. So by default, as we have seen before, there are three basic Sighash types, namely all, none, or single. By default, it's none. Basically, our signature cover all, and also Sighash preimage cover all the inputs as well as all the outputs of a transaction. What if we use none? So basically, the preimage covers all the inputs but covers none of the output. How about single? Basically, you cover all the inputs and one more output, which is the same as the same index with the input that the contract we are trying to unlock from. It's called single. So besides these three basic types, there's another modifier called anyone can pay. So basically, if you look at all these three, they only control the outputs. So basically, combined with anyone can pay, they can also control what inputs are going to be included into the preimage to be signed. So basically, anyone can pay says I only include the input that the UTXO I'm the spending in is from. I do not care any other inputs. So you can combine this with all others. So if you combine with all, you can say, okay, no, I only sign the input I'm in. I forget about every other input. Same for none and for single. So what can we use this for? So many times you have cases where you don't want to sign all the inputs plus all the exports because you want to have the flexibility to mutate or to manage the inputs or some part of the output after you have signed. So let's see one example. Again, we have shown this counter contract before when we are introducing the stateful contract. Basically, it does is inside the contract, there's a counter state which is incremented every time the function from this contract is called. So we can show it again. So basically, this is how it evolves. You can see here, there's only one input and one output, because every time when we try to run this contract, we have to pay miners the fee to run it. So as we keep going, you can imagine at one point all the Bitcoins locked in a initial state that will be gone, and then the whole contract gets stuck, right? So for that to keep going, potentially forever, as long as it get paid, we add two things here. One is we add another output, which is the change of the output. So if we have more inputs after then the output, even after we pay the miner fee, we can get a change address back to us. So for that to happen, we also add using the anyone can pay. So what does this do? So it means anyone who wants to the contract to keep going, they can add their own input and sign it, and thus keep the contract keep going. Anybody who wants to contribute fund to cover the transaction fee, they can do so via this anyone can pay flag. So how do we do this? Again, instead of again, we also have a Sighash preimage using the output transaction technique, but instead of using the default one, we use a customized version, which enable us to pass the Sighash type as well. So here, type we can use, for example, as we see here, we combine anyone can pay and all. And fork ID, this you can think about this. This has to be always in. Basically, this is coming from different forks, and in Bitcoin SV today, we always use this one. So let's not worry about this. So after this, all this code is very simple. Is exactly as what we had before in the basic counter example. And with one small change here, because we have an additional change output. So we have two outputs, the counter output containing the state of the contract plus an additional change output. So again, we can combine them two and hash and check it against the hash of the outputs in the preimage to make sure this is exactly what output we are expecting. So again, I think we just showed one example of using or combined with anyone can pay. We can also use a single. Basically, if we have a contract, state for contract, and we only care about we propagating to the next output. We don't care about other outputs, or sometimes we don't even care about other inputs. We can use single combined with anyone can pay. And there are a lot of there are 6 combinations actually you can use, so which give a lot of flexibility to control exactly which outputs and inputs we want to include in the signature, so that it cannot be mutated after we sign it. I hope this is useful, and hope to see you in future videos. Thank you.